Binary logistic regression for a predictor that is binary in SPSS. Logistic regression is a statistical test that can be performed when the outcome or the dependent variable or the response variable is binary, which means that it has two categories in it or two levels. Yes, no, have disease, doesn't have a disease, have diabetes, doesn't have a diabetes. And the second variable, which is the independent variable or the exposure variable or the explanatory variable, can be binary. Again, binary means that has two levels in it, such as the sex or the gender, male or females. To perform the binary logistic regression with a binary predictor, the outcome has to be binary and the predictor has to be binary. The objective of doing binary logistic regression is to find out whether there is a relationship or a link or association between the predictor and the outcome, and whether the predictor can predict the outcome. Here in this SPSS data sheet, I had inserted 100 cases or participant. There are two variables here, one for gender and one for heart diseases. So the first one, which is the gender, is a binary or binomial variable, have two levels in it, males or females. If I click on the variable view and click on the values for the sex, 0 is assigned for females and 1 is assigned for males. So here we have one variable which is binary or dichotomous, have yes or no, or have male or females in it. 1 for male and 0 for females. The second variable, which is heart diseases, whether you have a heart diseases or not. If we click on variable view, then in values, and the 0 value is assigned for no heart diseases and 1 is assigned for heart diseases. So here we have a variable which is binary. If I click on that icon, you can see it's coded 0 or 1. So here we have two variables. One of the variable is the outcome, which is the heart diseases, whether you can get a heart diseases or you will not get a heart diseases based on the data inserted here. So to find out whether there is association or relationship between the gender and possibility or probability of getting heart diseases, binary logistic regression can be performed. And the condition for performing that test is fulfilled as there are two variables. One of them is the outcome, which is binary, and the other one, which is a predictor, which is also a binary. Before we start, let's check the frequency for each variable. If we click on Analyze Frequencies and then drag the sex to the variable box and the heart diseases, click on Statistics and nothing to choose from here. Let's just click on OK. Again, multiple tables are generated. The first table shows that there are 100 cases with no missing values for sex and heart diseases. For the first variable, which is the predictor, which is the sex, there are 52% of female and 48% of males. And for the heart diseases, 44% have no heart diseases and 56% have heart diseases. To perform logistic regression binary, click on Analyze, scroll down to Regression, and then scroll down and select the binary logistic regression. Reset that window, and in that window, since we know that the heart diseases is the outcome or the dependent variable, this is the variable we want to find out whether the predictor, which is the sex, which is a binary, can predict probability or possibility of having heart diseases. Drag that into the box here. Since we have here a predictor that is binary or categorical, click on categorical, drag the 6 here, although it is just having only 2 levels in it, I'm going to set the 0 for the first, which means that male will be compared to females. Click on continue. For options, I'm going to select classification, plots, Hosmer, goodness of fit, and confidence interval for the exponential p. Click on continue, click on OK. Multiple tables are generated. The first table shows a summary for the case or cases. As shown, 100 cases, no missing values or cases. The second table is the dependent variable, which is the outcome, which is the heart diseases. As shown here, it has been given a value of 0 for no heart diseases and 1 assigned for heart diseases. And for the categorical variable coding, females are given a value of 0 and male are given as a value of 1. Moving to this table, which is variable in the equation, this is a very important table, shows here the coefficient value and the test which is used for binary logistic regression, which is called Wald test. Standard error is generated, and degree of freedom, significant p-value, and exponential p, which is the odds ratio. Moving to the section here, which is for method enter, the important table also here is the model summary. A model is generated by trying to fit the predictor into the outcome to generate a model in which the possibility of the predictor can predict the outcome. Again, looking at the R square here, which is the value here, which is 0.735. This value means that 73.5% of the variation in the outcome, which is the heart diseases, whether you have a heart disease or not, can be explained by the predictor, which is the sex, whether male or a female. So the sex or the gender of individual can explain the variation in the outcome. Jumping to the last diagram here, which is very important, as shown from this diagram, predicted probability is of the membership for HD. So we are here calculating the probability or the chances or the odds for heart diseases, possibility of heart diseases. The table here is also an important output for the interpretation of the result from the analysis, binary regression. There's a value is given here for the coefficient, the standard error, the Wald test, the degree of freedom, significant as it is less than 0.05, and 95% confidence interval for the exponential, which is the odds ratio. This is for the predictor or the variable, which is sex, and again given a value of 1. Here we are comparing the males to females. So the way to read this result or interpret this result, it shows that there is a significant association between the outcome, which is possibility of getting heart diseases, and the predictor, which is the gender of the individual. As shown here, the males have a 224.5 odds of having heart diseases compared to females. So the males had an increased chance of getting heart diseases with an odds of 224.5 related to the females. So this is the way to perform binary logistic regression with an outcome that is binary, which has 2 levels in it, and a predictor, which is binary, have also 2 levels in it, to find out whether there is a relationship between both variables and whether the predictor can predict the outcome. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box and activate the notification bell to receive the recent and latest release into the channel of several different video clip, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovie, R Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovie, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.